Good morning, students. Very good morning. Last class we discussed the concepts of translation process, that is related to compiler and interpreter translator programs, how to convert by using compilation process, by using interpretation process. Today we discuss the concepts of what are the differences between the compiler and interpreter. You know very well, these two, compiler and this interpreter, these two are translator programs, are called as, they are system programs, system softwares. How we differentiate these two concepts, that is compiler and interpreter? See, the criteria here is the comparison in between compiler and interpreter. Here the criteria is, first one is input. So based on this input we compare these two translator programs. Okay. So when we convert any source code program into object code, okay, so we require either compiler or interpreter. So here so many differences are there in between the compiler and the interpreter. Here the first one is, we compare basing on, here first one is input, second one is basing on output. Here the criteria is output. Next the third one is according to memory how they are classified, and according to errors concept how they are differentiated. Next, according to always required. Always required means here compilation or compiler software is required or not. So depends on that we compare these two compiler and interpreter processes. Next, coming to workload. So in compiler how the differentiate, how it is differentiate with the interpreter basing on this workload. So first we start our differentiation, starts with input, the first criteria. See here for these both two programs, translator programs, one is compiler and interpreter. So input is source code program, that is our Python code. Okay. So this Python code, source code program can be converted into object code. That is our target. Okay. See here the compiler takes the entire program file. The entire program file, that is .py file, can be taken as a single, okay, sure. Okay, then it convert it into object code. But when it comes to interpretation process, it takes, okay, at a time single line of code, or one for loop instruction, or one if instruction, like that. So it takes one section of code or a single line of code and it converts it into object code. But it takes the entire program, all the instructions and the entire program and the entire file can be taken as single input. That is the difference between these two, compiler and interpreter. When it comes to second point, output. See here the output, it generates, this compiler process generates after completion of the second step, means compilation process, both analysis and synthesis subphases completed, it generates this intermediate object code. It generates intermediate object code which is somewhat near to assembly language program. Okay, which is a low level language. This intermediate object code is somewhat near to assembly language which is in low level language. Okay, then when it compares to interpretation process, in this it doesn't generate any intermediate object code. See, that is the concept of output criteria. Next, third criteria is memory wise. See here, memory. So it requires more memory, means, so when we using compiler to translate our source code program into object code, here we requires more memory. Why? Because we consider here entire program at a single shoot. Okay, so that's why here all the lines we are taking it as, consider it as at a time. That's why it takes, okay, to convert all the lines, it takes some time. So for all this time, it requires this more memory. So it consumes more memory to store all these instructions in memory. That's why it requires more memory when it compares to interpretation process. Why? Because here in this interpretation process converts only single line of code, but it takes all the lines at a time. So that's why it takes more memory when it compares to interpretation process. In this interpretation process, it requires less memory. Why? Because it converts at a time single line of code, a single set of instruction. So that's why it takes less memory when it compares to compiler. So that is the concept of memory wise. Next, coming to the next concept, errors. See, so when in this process, compilation process, if any errors are there, the compiler immediately displays all the errors at a time in a single, okay, shoot. It displays list of errors with that error number and error information can be displayed, error, where it is located, okay, in which line number the error is located. That also displayed here in this compilation process. It displays all the errors at a time. That is concept here. But here it displays the single line of error at a time. Why? Because it converts at a time single line of code. If any error is there, then it displays that error. So it displays only one error at a time. That is the concept here. So it displays the error of a single instruction at a time, but it displays all the errors at a time, and it displays errors and error number where it is located, that is error line number, and the required information, error information, it is displayed here for the entire program. So that is the concept of regarding errors. Next, coming to always required. See, here the compiler is a software. This compiler is not required after when you are executing, after the exe file is completed. So after exe file is prepared, then this compiler software is not required to execute this exe file. Exe file means here executable file. So that's why it is always not required. That's why I write here no. Why? Because here compiler software no longer required to execute the exe file. So exe file is executed automatically or independently with the help of operating system. Here in that particular situation, compiler is not required to execute that compiler software. Okay, so coming to this interpretation process, the always it requires this interpreter software always required. Why? Because it at a time it doesn't generate any exe file. In interpretation process, it doesn't create any exe file. Why? Because it converts at a time a single line of code. In that single line of code completed, then it starts again next second line of instruction, line of code to convert from source code program into object code. So that's why here for each and every line conversion, the interpreter software is required. That's why always here it is required, this interpreter software is required to convert this object program into this source program into object program or object code. So it is always required here. Next, coming to workload. So here in this compilation process, once all the compilation process is completed, and it prepares an exe file, executable file. So next, suppose if you are not any changes are there in our Python code, then we need not to create. We need not to create. So recompilation is not required here. Why? Because we not change any code here. That's why we rerun the same exe file without changing the code or without changing any effects of the exe file. We execute number of times the same exe file. Why? Because up to we not change any instructions or code. Suppose if we are change any instruction or code in that Python file, then we require recompilation is required. Up to now, we not require recompilation process. But this time we change the code. That's why we require recompilation process. Okay, that is the concept. Here, workload criteria. So here, compilation once completed, here that exe file stays always. We need not to recompile again and again. We need not to re-execute that exe file. So we create only one exe file without changing any code. Then we number of times execute that exe file. Okay. But when it compares to interpretation process, in this interpretation, is required each and every time execute this interpreter process. Why? Because here it converts at a time single line of code. Okay, here workload is here. This interpretation software is required each and every time. So these are the points that are compared basing on this criteria. Here the main objectives of comparison here. First one is input, second one is output. Basing on this output, memory wise and error wise, and always compiler software is required or not. This translator software is required or not. Here the workload. So if any recompilation is required or not. Here workload means any recompilation is required or not. So this is the today's concept. Next class we will discuss remaining concepts. Thank you, students.